question 34. Which diagram, C or D, best represents what occurs when each of the following ionic compounds dissolves in water? So, looking at diagram C, it doesn't look like it really dissolves. It looks like it's all clumped up. D looks like it's dissolved. So I would reword this question. Which diagram best represents what occurs when each of the following ionic compounds is added to water? It either dissolves or it doesn't dissolve. So C is insoluble. It's ionic compound is insoluble. It'll do something like that and stay all clumped up, or it's going to be soluble. And the cations and the anions become separated from one another. So basically, this question is asking, are these soluble or insoluble in water? And to answer that, we can refer to the solubility rules in section 8.3b on page 281, and I have those rules right here. So the first one, RB. Now this is rubidium bromide, and this is going to be soluble because all group 1 cations, if the ionic compound contains any of these cations, like rubidium, it's going to be soluble. So rubidium bromide is made of these ions, rubidium plus and bromide minus, and because it contains the rubidium, it is soluble, therefore it would look like solution D. I would call this mixture C and this solution D. Now what's next? This one right here, so that's zinc and then carbon and 3 oxygens. So this is a zinc plus 2, and that's a polyatomic anion, that's the CO3 minus 2. So this is called zinc carbonate because that's zinc and that's carbonate. Now, if it's not mentioned as being soluble in here, you should assume it's insoluble. And nowhere in here does it say compounds containing zinc or compounds containing carbonate are soluble. So I'm going to assume that zinc carbonate is insoluble, therefore it looks like mixture C. Now what's next? You got AgCl. This is made of the silver plus ions and the chloride minus anion, so we're going to call this silver chloride. And this is insoluble. And the rules here state that chlorides, when an ionic compound contains chloride, it's soluble except for when it's matched up with a silver plus, this one or that one. And here we're talking about the case where we got silver plus and chloride minus. So that's one of the exceptions of the solubility of the chlorides. So this is insoluble, therefore it looks like mixture C. Next is NH4OH. This is the ammonium plus cation. This is a polyatomic cation. And this is the hydroxide OH minus anion. So this is called ammonium hydroxide. And right here, compounds that contain ammonium are soluble. So this guy is soluble. It's going to look like solution D. Last one, MgSO4. This is the magnesium plus 2 cation and the sulfate SO4 minus 2 anion. So we'll call this magnesium sulfate. This is going to be soluble because sulfates are usually soluble and magnesium is not an exception. So this is soluble and therefore it looks like solution D.